So in the diagram over here, what we see is a couple lines, line EF and line GH, that are crossed by a transversal, line AD right here. And so the question we're going to look at is, how can we prove that these two lines are parallel, line EF and line GH? Because if I look at this picture, it certainly seems like they're parallel. It seems like if they keep going in both directions, they're never going to cross each other. It looks like they're parallel. But our question is, how can we prove that they have to be parallel? And so the answer is, we're going to use what's called the converses of the four things that we learned in one of the previous videos: the same side interior angles postulate, the alternate interior angles theorem, the corresponding angles theorem, and the alternate exterior angles theorem. And we're going to be using the converses of these. So let's real quick remember what a converse is, right? So a converse says, if my original statement was if P then Q, the converse turns that into if Q then P, right? So maybe I should change the way I wrote that. I don't want to say that the converse is if P then Q. I want to say that the converse says if Q then P. So how does this work? Well, remember we said in a previous video, we said that if two lines are parallel, let's say if line M is parallel to line N, or actually, you know what, let's use the lines that we have in this picture. If line EF was parallel to line GH, if that was true, then there's four things we could say would have to be true. We could say that the same side interior angles would have to be supplementary. We could say that the alternate interior angles would have to be congruent. We could say that the corresponding angles are congruent. And we could say that the alternate exterior angles are congruent. So we would be able to state these four things would be true if the lines are parallel. And so this first one is the same side interior angles postulate, and then the next three are these three things, right? So the converses of each of these statements would start off by saying, if the same side interior angles are supplementary, then the lines would be parallel. And if the alternate interior angles are congruent, then the lines are parallel. And if the corresponding angles are congruent, then the lines are parallel. And if the alternate exterior angles are congruent, then the lines are parallel. That's what the converses of these statements would say. So we can use the converses of these because it turns out that the converse of each one of these statements is also a true statement. It's a true conditional. So we can use those to prove, using the given information that we see in this picture, that these two lines must be parallel. Let's take a look at how we're going to do that. All right. So let's start with the same side interior angles postulate. I look at this picture and I see, okay, I have a 76-degree angle for angle BCH, right? Angle BCH is 76 degrees. And I have a 104-degree angle here for angle ABE. Now, that 76-degree angle is an interior angle, and its same side interior angle would be this one right here, angle FBC. This angle would be a same side interior angle. So if I could somehow show that this angle plus this angle would equal 180, then that would use the converse of the same side interior angles postulate to prove that these lines are parallel. And what I would notice is, hey, look, if this is 104, then I should be able to say that this angle over here is also 104 because they're vertical angles. And now I can say, since the measure of angle FBC plus the measure of angle BCH equals 180, that means that line EF has to be parallel to line GH, because what I've just shown here is I've shown that the same side interior angles are supplementary, and by the converse of this postulate, that means that the lines have to be parallel. So now let's look at how we could use maybe alternate interior angles and show that those alternate interior angles are congruent, and that would make the lines parallel. Well, I might look at angle BCH right here and angle BCG right here, this guy. And I might notice that these two angles are a linear pair. So they have to be supplementary no matter what. Linear pairs are always supplementary. So if this angle right here is 76, then I could perhaps say that this angle right here has to be 104 degrees because, again, these two have to be supplementary. I've already determined that this is a 104 degree angle, and now I see that I have a pair of alternate interior angles that are congruent. So I can say, since the measure of angle FBC is equal to the measure of angle BCG, that would mean by the alternate interior angles theorem converse, those two lines must be parallel. Right? I use the converse of this statement. Since the alternate interior angles are congruent, I've proven that they are congruent, that means the lines have to be parallel. So now we can look at the corresponding angles theorem. The converse would say if the corresponding angles are congruent, then the lines are parallel. And I could look at this and I could maybe notice, hey look, they started off with the given information before I figured out that these were 104. They told me that these two angles have to be congruent. They didn't tell me right away what their measures were, but they told me that they have to be congruent. And so I can say, since angle EBC is congruent to angle GCD, that would make line EF have to be parallel to line GH. So again, the two angles I'm talking about here is EBC, right, this angle, and GCD, this angle right here. Since they're congruent, the lines have to be parallel by the converse of the corresponding angles theorem. And lastly, let's take a look at how the alternate exterior angles theorem might work in this example. So the converse of the alternate exterior angles theorem would say if the alternate exterior angles are congruent, then the lines would have to be parallel. So let's look for a pair of alternate exterior angles that are congruent. Well, I see I have one exterior angle up here at 104, right? Angle ABE is 104. Now, its alternate exterior angle would be this one, because it would be on the opposite side of the transversal and on the exterior like that one is. So angle HCD would be the alternate exterior angle with this one. Do I know that that's 104 like that one? Well, yeah, I do, because I've already determined that this one's 104. And this guy right here must be also 104 because they're vertical angles. So I could maybe come in here and say, okay, that guy there has to be 104 degrees. And now, since I have 104, 104, a pair of alternate exterior angles that are congruent, I can say that since angle ABE is congruent to angle HCD, EF must be parallel to GH, and again that is using the converse of the alternate exterior angles theorem, that since the alternate exterior angles are congruent, those two lines have to be parallel. So again, what we looked at ways that in this picture we can actually prove that these two lines have to be parallel. They look parallel, but we can prove they're parallel by some of the information we were given and applying that given information to one of the converses of this. It just so happened that we could actually pick and choose any which one we wanted with the given information, but we could use the converses of these theorems along with the given information they started us with to prove that these lines have to be parallel.